Light intensity is crucial for photosynthesis. Hence, if green leaf plants are placed in a dark environment, photosynthesis will not occur. It is important for the plant to receive enough light during photosynthesis, as without it, it will not occur at the same rate. Even water, carbon dioxide, and suitable temperature is given to the plant. For this exact reason, light intensity can affect the rate of which photosynthesis to occur. The material that we need in this experiment is plant. This plant called crepe jasmine with its scientific name Tabenem montana divaricata, distilled water, ruler, syringe, beaker, sodium bicarbonate, straw, and table lamp.
First, we need to choose one species of plant and find the common name or the scientific name of your plant. Next, by using a straw, get 10 leaf discs from the plant that we choose. Next, we remove the plunger from the syringe and put the leaf disc into the barrel of the syringe. After that, we tap the leaf disc down to the tip and replace the plunger into the syringe and must be careful not to damage the leaf disc. Next, in a beaker, mix 0.5 gram sodium bicarbonate with 50 ml water. Draw about 6 to 8 ml of bicarbonate solution into the syringe, and the leaf disc should float in the solution. Next, hold the syringe with the tip up and expel the air by gently pushing on the plunger. And then plug the tip of the syringe tightly with your finger and gently pull on the plunger, creating a slight vacuum. You should see tiny bubbles coming out from the leaf disc, and hold the vacuum for a few seconds and then release the plunger, letting it snap back, and some of the disc should begin to sink. When all the leaf discs have settled to the bottom of the solution, carefully remove the plunger and pour the disc and solution into the cup. The leaf disc should settle to the bottom of the cup. Next, set up your torchlight so that it is suspended about 3 cm above the beaker. Turn on the light, start a timer, and watch the leaf disc at the bottom of the cup. And notice any tiny bubbles forming around the edges and bottom of the disc. After several minutes, the disc should begin floating to the top of the solution. Record the number of floating discs every minute until all the discs are floating. Once finished, remove the light and put the cup in the dark area for at least 15 minutes. Repeat step 3 until 14 using the same experimental setup, but this time set up the torchlight with a distance of 10 cm above the beaker, and then we record the observation. For discussion 1, when you apply a gentle vacuum to the leaf disc in solution, the air is forced out and replaced with solution, causing the leaf to sink. For discussion 2, bicarbonate solution is taken up by the plant to provide carbon dioxide. But if there's no baking soda, the carbon dioxide will not provided to the plant. Hence, there is no oxygen was produced and the leaf will stay sink. For the third discussion, bicarbonate solution is taken up by the plant to provide a source of carbon dioxide. But if there is no baking soda, the carbon dioxide will not provided to the plant. Hence, there is no oxygen was produced, and the leaf will stay sink at the bottom of the solution.
Okay, for the fourth discussion, when you put floating leaf discs in the dark, they will eventually sink. Why? This is because without light energy, no photosynthesis will occur, so no more oxygen gas will be produced. So in conclusion, if light affects the rate of photosynthesis, then the more light there is, there will be a greater rate of photosynthesis. So my data supported my hypothesis because when the discs were closer to the light, the discs rose to the surface faster than when they were further away from the light. Throughout the experiment, there could have been errors were made, which would affect the result.